Hello students, today we are going to take up the topic Analytical Chemistry. This is chapter 4 of ICSE Chemistry. First of all, we would like to understand the meaning of Analytical Chemistry. Analytical Chemistry, this term comes from analysis. Analysis meaning is to find, to determine the chemical components present in any salt. Now see, analysis is determination of chemical components. So chemical components can be determined in two ways. First, it is quantitative. Second is qualitative. Quantitative means that how much quantity. Qualitative means what are the components. For example, I am having unknown salt. I know that this salt, after there is a series of experiments we have to do in that. After series of experiment, I came to know that this salt is made up of two ions, one is cation and the second is anion. So now if I will come to know about the type of cation and anion in that salt, it means that type of analysis is called qualitative analysis. Now the next point is, if I will come to know that how much is that ion, how much is the percentage of that ion or how much is the percentage of that atom, that means it is quantitative. Let us see with a simple example. If I am having sodium chloride salt, if I am finding this salt is containing sodium and chlorine, this is the meaning of qualitative. And if I would be able to find out that how much is the percentage of sodium, how much is the percentage of chlorine, that is quantitative. This is the meaning of quantitative and qualitative analysis that comes under analytical chemistry. So this is the basic thing. Now before starting further about this, let us see that we are going to identify here cations using lab reagent. Lab reagent, this is the chemical used to get the analysis. For example, sulfuric acid is a reagent, sodium hydroxide is a reagent, potassium hydroxide is a reagent, ammonium hydroxide is a reagent. So these are reagents which are normally present in chemistry lab. Okay, so now our topic of study here is we have to identify cation. Cation means which is having positive charge by lab reagent. Which lab reagent we are going to use is sodium hydroxide. Sodium hydroxide, we know that NaOH, sodium hydroxide, and reagent, second reagent we are going to use is ammonium hydroxide, NH4OH. As you know that sodium hydroxide is a strong base and ammonium hydroxide is a weak base. Strong base is completely ionized. It gives maximum number of OH reactive ions. But ammonium hydroxide is a weak base which undergo partial ionization and will not give that much OH ions as compared to sodium hydroxide. Means to say that sodium hydroxide will give more OH reactive ions, ammonium hydroxide will give less OH reactive ions. So now let us learn this mnemonic to understand more. Ka, Phi, Kap, Jara, Pakadana. What is the meaning in this? Ka means calcium. Phi means ferrous and ferric. Kap means Cu2 plus and P means Pb2 plus. Jara, zinc, Pakadana, ammonium. Okay, so these are the ions we can relate with the mnemonics that is called Ka, Phi, Kap, Jara, Pakadana. Please do understand, please do remember this, and so that all the ions we can remember, we can use number of questions being asked from this topic in board exams. So before going further, I would like to add few things here. The salt we were talking of qualitative and quantitative analysis. The salt can be colorless and colored. Normally the salt which belongs to representative elements that are colorless, and the salt which represent the transition elements that is having color. So Okay, let us move further again with the same topic here. Reagent we are using sodium hydroxide and reagent we are using ammonium hydroxide. I want to identify cations. So the meaning here involved here is I am adding sodium hydroxide and ammonium hydroxide in a given salt solution. Let us say I have been given the salt solution of calcium salt like calcium chloride, calcium nitrate, calcium carbonate. If I am taking that salt solution, if I am adding sodium hydroxide, what is going to happen? Their white precipitate will be formed. So this all the color we are given is, this is the white precipitate which is insoluble in excess, or we can say sparingly soluble in excess. Calcium hydroxide is sparingly soluble in excess. And this salt, calcium salt, will not give reaction with ammonium hydroxide. As we have discussed that ammonium hydroxide is a weak base, the OH negative ion concentration may not be sufficient to cause the precipitation. Here OH negative ion concentration is in large percentage, large quantity, so their precipitation will take place. White precipitate of calcium hydroxide will be formed, but here in case of ammonium hydroxide there won't be any precipitate. Next thing is regarding to these are the reactions. Sodium hydroxide will undergo reaction, ammonium hydroxide will not undergo reaction because of lower concentration of OH negative ions. So now the second point we are going to discuss now here is about ferrous salt and ferric salt. So if you see from here, ferrous salt, ferrous means any ferrous salt like ferrous chloride, ferrous salt, any ferrous salt, when you treat with sodium hydroxide solution, that is a reagent, it gives us dirty green precipitate, and when you add that reagent in excess, this precipitate will remain insoluble. So dirty green precipitate word also we should add. Okay, so because we have added here in the some top portion here, so always precipitate word we should add in each of the color of the respective salt. Now here is, if you see there, ferrous salt will give dirty green precipitate and ammonium hydroxide also will give dirty green precipitate. It is insoluble in excess. Mean to say that both the results are same. So see here, if you are taking ferrous, here it is ferric. If I am taking ferrous, you know that it will be formed as FeOH twice. Okay, and here also dirty green precipitate of ferrous hydroxide, FeOH twice. Now here you have taken ferric, ferric will give reddish brown precipitate, FeOH thrice, and similarly here also it will give reddish brown precipitate of FeOH3. Means to say that ferrous and ferric, the reactions with the sodium hydroxide, strong base and weak base ammonium hydroxide remains same, and the observations are also same with these two salt, ferrous and ferric. Now let us come to cupric salt or copper 2 plus salts, copper sulfate. So when you treat with sodium hydroxide, it gives us copper hydroxide, which is a pale blue precipitate, and it is insoluble in excess of sodium hydroxide. But here the difference is there. The color might be same, pale blue only. But when you add ammonium hydroxide in excess, it will give us deep blue solution. Please, I will try to repeat. It is a deep blue solution. Previously it was pale blue precipitate. It means on addition of excess of ammonium hydroxide, pale blue precipitate changes into deep blue solution. Why it is so? It is due to complex formation. So please do check from your book all these reactions of excess. Although reactions will not come in the exam for the excess, but still we can just once have a look so that proper understanding should be there. Similarly, next is lead salt. So lead salt are giving us chalky white precipitate. Please don't forget to write precipitate word. Precipitate word is important. Here summary we are given, therefore it's not written like that. Chalky white precipitate, and it is soluble in excess of sodium hydroxide. Okay, now here also again soluble. Why? It is due to complex formation and sodium plumbide is formed in that. chalky white precipitate again, but insoluble in excess. It won't form any complex salt which is soluble. The reactions here is lead nitrate when treated with sodium hydroxide gives us PbOH twice, which is giving us chalky white precipitate. Now comes to the zinc salt. Zinc salt, what is the difference? It will give gelatinous white precipitate. So please see the difference between calcium and let us say calcium and lead and zinc. Three of these salts are giving same precipitate, white color, but the difference is there. Calcium is white, giving reaction with the sodium hydroxide only. Ammonium hydroxide will not give reaction. Zinc will give gelatinous white precipitate, and this precipitate is soluble in excess. But if you talk of lead, it will give you chalky white precipitate, and it is soluble in excess of sodium hydroxide, but remains insoluble in excess of ammonium hydroxide. So these things are very, very important. So we will do all these things in the practical lab also, but still you can just have this keep in mind so that it will be easy to understand during the experiment. Now the next is, the last point is ammonium salt. So this part is very, very important in terms of determination of ammonia gas also. And if any ammonium salt like ammonium chloride is there, ammonium carbonate is there, ammonium nitrate is there, any ammonium salt when treated with sodium hydroxide, it will give us ammonia gas. And you know that ammonia gas is a colorless gas having pungent smell, and this gas can turn natural reagent to brown, or it can turn moist red litmus blue. So I would like to summarize one more point here. So here we have discussed this mnemonic ka fi kab jara pakdana. So Ka means calcium. Calcium is giving us white precipitate. That precipitate will be given only with sodium hydroxide. Ammonium hydroxide is not giving that precipitate. And this calcium hydroxide precipitate is sparingly soluble in excess of sodium hydroxide. Similarly, ferrous will give dirty green, ferric will give reddish brown. And these two salts giving the precipitate, ferrous hydroxide and ferric hydroxide, and the reactions remain same with sodium hydroxide and ammonium hydroxide. No, it won't change even in excess of sodium hydroxide or ammonium hydroxide. Copper 2 plus, it will give pale blue precipitate with sodium hydroxide and ammonium hydroxide, but in excess there is little changes there. In excess of ammonium hydroxide, it will give inky blue color solution, deep blue color solution. Pb2 plus also, it will give chalky white precipitate with sodium hydroxide and ammonium hydroxide, but it is having changed status when you add excess amount of reagent. If you add excess of sodium hydroxide, this precipitate is soluble, and if you are adding excess of ammonium hydroxide, this precipitate remains insoluble. Zinc is having two common things, like gelatinous white precipitate formed with sodium hydroxide and ammonium hydroxide, and colorless solution is formed in both cases. Ammonium ion, when you treat with the sodium hydroxide, it gives us sodium chloride, water and ammonia. Ammonia is a colorless pungent gas. So this thing we have discussed, and this gas is having basic test with the moist red litmus, and it will turn into blue. And if you go for Nessler reagent test, it turns Nessler reagent from colorless to brown. Okay, so now these are the colorless salts of ammonium, sodium, potassium, calcium, magnesium, aluminium, lead, zinc. Lead, zinc is exception, but all other are representative elements. The salt of representative elements are colorless in nature. Okay, and colored salt, we are talking of salt of copper, nickel, manganese, cobalt, ferrous, ferric, chromium. These salts are colored in nature, and when you dissolve, this color is due to formation of ions. Next very important topic is alkali ion treatment with zinc, lead and aluminium. These three metals are specific. Why? Because these react with alkali to form soluble complex, like zinc plus NaOH, hot and concentrated, give rise to sodium zincate and hydrogen. Aluminium is giving us sodium metaluminate plus hydrogen, and lead is giving us sodium plumbite plus hydrogen. The point here I want to discuss here is, please remember this reaction. This reaction is very important, and water is there, because in the question they will not write like that. They will write like that is, write the reaction when aluminium reacts with hot and concentrated solution of sodium hydroxide. They will not write water. So you have to add water here. Aluminium, water and NaOH give rise to NaAlO2 plus hydrogen. And see, very easy to balance, 2, 2, 2, 2, 3. So this is a shortcut method to keep in mind all these things, otherwise it will take time to balance this reaction. Next is oxide and hydroxide of zinc, lead, aluminium are amphoteric. Amphoteric means this is having property both as acid or as well as base. Let us say, for example, zinc oxide, when treated with HCl, it gives us zinc chloride. It means it is acting as a base. So if you treat zinc oxide with NaOH, so again sodium zincate is formed. It is acting as acid. So therefore, this is having both properties of acid as well as base. Therefore, it's known as amphoteric oxides. So please do remember these three metals, zinc, aluminium, lead. Oxides and hydroxides are amphoteric in nature. Now see the reactions here and reactions here. So what is the difference between these reaction and this reaction? If you talk of zinc NaOH, here hydrogen was there, here water is there. So if zinc oxide is changed to zinc oxide, hydrogen is changed to water. Similarly, aluminium is changed into sodium metaluminate plus hydrogen. Aluminium oxide will change into metaluminate plus water. PbO, Pb to PbO, hydrogen to water. So these reactions are very easy to remember. And next is alkali on treatment with zinc hydroxide, lead hydroxide. Now hydroxide is there. Previously we talked about metal, then we talked of metal oxide, and then third is right metal hydroxide. So here zinc hydroxide on treatment with form is Na2ZnO2 plus water. Only the quantity of water is doubled now. Aluminium hydroxide gives rise to sodium metaluminate plus water, PbOH twice plus NaOH, sodium plumbide plus water. So this is all about the analytical chemistry. As a recap, I will tell you coffee cup jara pakrana. This is very important. Any question is coming in terms of that. Let us say one question came like that: distinguish between ferrous chloride and ferric chloride. How you are going to do? You know that ferrous and ferric, you can use any of the reagent like sodium hydroxide. If you add sodium hydroxide in ferrous chloride, it will give dirty green precipitate which remains insoluble in excess. And on the other hand, it will give ferric chloride gives reddish brown precipitate which remains insoluble in excess. Sometimes the observation based question can be asked. Observation question means, what do you observe when a copper salt is treated with ammonium hydroxide in small quantity than in excess? Then you know that copper sulfate when treated with ammonium hydroxide will give deep blue precipitate, and on excess of ammonium hydroxide gives rise to inky blue solution. Basically, ultimately everything depends on all these things. This mnemonics, coffee cup jara pakrana. If you are able to remember that is very nice, and we can solve any number of questions which can be asked. So I would like to request you to practice and read the book, so that the concept coverage will be there for this part. Thank you.